All right, so we're going to start the notes now for 6.2. This is going to be page 97, and then that purple page you were working on is also going to be page 97. And I'm going to show you how this page ties in with your notes. So we're in 6.2 in your book, and there is this button on your calculator. It's in two spots. One is above the LN. This is the one we're going to use the most, and the other one is here above the division sign. So there's this number out there, and it's called E. And it was discovered by this guy named Leonhard Euler. So what Leonhard Euler discovered was, going back to that other purple page, is that when you start compounding interest, so that's how often they figure out the interest. If they decide they're going to pay you interest once a year or twice a year or 4 times a year, the more often they pay you interest, this answer that we get gets closer and closer to this number down here. And so as it turns out, if you go to your calculator and you type in on the second and then the division sign, E pops up, and E is worth this. And it's like pi because it never ends. This is as much as the calculator's going to hold, but this actually keeps going past the 8. So Leonhard Euler discovered, if you start paying me interest all the time, every second, every moment of the day, then my amount of interest is going to get really close to Euler's number, but it's never going to get past this. You're never going to get, if you're rounding this to money, $2.72, you're never going to get $2.73. You're kind of stuck at this. So he realized that and came up with a shortcut to this formula up here, because you guys wrote a lot of stuff down here and you pushed a lot of buttons in your calculator, and when you did that, that takes a lot of time. So he realized that there's a shortcut, and he came up with E, and the shortcut formula is on the back, and that's where E comes from. It's really this number worth, again, what the calculator says, 2.71828, on and on and on and on. But instead of writing this number, we use E, just like we use the pi symbol for 3.1415. So on the chapter test, you will be responsible for knowing E to certain values. So you do need to know that e to the first, anything to a zero power is 1. You'll need to know that e to the first power is 2.7. We're going to round it to the nearest tens. You also need to know then that e to the second power, and again, you could type this on your calculator. When you type this on your calculator, you're going to use the second and then this ln button over here, because this builds in an exponent for you. And that's going to be 7.4 when we're done rounding. And these are the 3 I need for you to know, and just to share, e to the third power, I think it was 20.1. Okay? So you need to have these 3 numbers memorized when it comes time for the test. So E, this irrational number, irrational numbers never end, follow the same rules as the stuff that we've done with bases and exponents. So next week, we are going to be revisiting Chapter 5, and we're going to have a fix-it day to fix part of Chapter 5 that didn't go well. It was a common set of problems, not just in your class, but in all the Algebra 2 classes. So, it'll just be a chance for you guys to fix that. So anyway, the idea is we can still simplify with E. Even though E, you could think of it as a letter or a number, you can still simplify this. And the rule is, when you have the same base, you add the exponents. In a problem like this, you had a problem similar to this on the test, and so just working with the 5/20ths, when you guys tried to simplify that, I got a lot of 4s, and you're right that you do want a 4, but it's where you put the 4 is what was the problem. So the idea of 5/20ths, you can simplify those by dividing both of those by 5, and the 4 goes on the bottom. And if this had been the problem on the test, I got 4, but not as a denominator, more as a numerator. And the 5 can become a 1. And then here you subtract the exponents, so I get 5 of them, and those 5 e's are on top because that's where they are to begin with, most of them. And then we're going to be fixing problems like this. This is where you distribute the exponents, and an exponent distributes to an exponent, and you multiply them. So this is e to the 15th. And it also distributes to the 7, but it's not 35. It distributes to 7's exponent of 1, and it's 7 to the 5th. And then you can go to your calculator to second and type in 7 to the 5th power. So let me just grab this. And when you type in 7 to the 5th power, you're going to get this. So this is going to be the answer, for instance, if this were the test and that fix-it part that I would expect you guys to have. So the same thing happens here. Even with the negative exponent, you're just going to distribute it in, and you multiply it, and that's just negative 5 times x. So we write it like that. You distribute it to this one's exponent, and so that's going to give you 5 to the negative 5th power. And negative exponents, if you recall, not everyone did on the test, move. So this 5 to the 5th moves to the bottom, this moves to the bottom, and then you need something on the top. And then go ahead, turn on your calculator. What's 5 to the 5th power? So the answer I'm going to be looking for on the test is this. Okay? So realize that this is still exponential growth and decay. And we're going to start to see E in some of the formulas, and it just stems from this, which we've already talked about in our colorful book. And when we did our colorful book, sorry, I'm just finding it. If you remember, G helped us in our table, grow our table by whatever G was. So in this problem, if I want to make my table, first I can see the y-intercept. It's 2. And then G is E, and E is, we're just going to use this 2.7. So to make my table, I can just start multiplying over and over by 2.7. So that's one way to do that. So if I take 2 times 2.7, I get 5.4. If I take 5.4 times 2.7, I get this. The other way I could get my table is to use the equation and put 0 in here and 1 in here and 2 in here and let the calculator do the work. If you're going to let your phone do the work, you need to realize that this e to the power would happen first, and then they would take that times 2 to get these numbers. So you can graph it, 0, 2. Here's one with 5.4. The other one doesn't fit. And since G is bigger than 1, we're going to have that decay shape. And remember, exponential growth and decay has that wall. And for now, that wall, called the asymptote, is the x-axis. And next week, we'll look at when the wall is in a different spot when we do some more graphing. Okay? So you can do all the things that we've done before. You can work with E in exponents. You can work with E in a graph. And now we're going to work with E in a formula. So first, there's a mistake. Over here, I didn't type this in correctly. So cross that out. This should be the formula. So anyway, when you guys did this, again, this guy Euler realized he didn't want to type this all into his calculator over and over again. So he came up with a shortcut to this formula. Because if he was always just going to get this number, then why not use that number instead? So this formula is now modified into this. And they nickname it the PERT formula. But P, this is still, they're both stemming from this. What you begin with, the y-intercept, that's P, that's your principal. So here it is here. G in this formula is all of that stuff in the parentheses. And now G is E. And then you've got your exponents and your exponent and your exponent. So we're going to start looking at this. So if you see compound and then they use the words daily or quarterly or monthly, you're going to use this formula. If they don't use the word compound, you're using this formula. And if they use the word compound continuously, you're using this formula. So those are our different formulas. All right? So you and your friend both decide to invest $2,000. Your friend invests in an account that pays 8% and compounds quarterly. And you invest in an account that compounds continuously but at a lower rate, at 7.5%. So who's going to have more money after 20 years? So there's you. And then there's your friend. So we're going to start with you first. All right, since you're investing in an account that compounds continuously, we're going to be using this formula. So to get our answer, we need our principal, the initial amount. So you're investing $2,000. You're going to use E. and then your rate. So you're at a rate of 7.5%, which is 0.075 as a decimal. So 0.075, and then your time is for 20 years, so times 20. So turn on your calculators, and I would encourage you guys to practice this because third hour ran into a lot of problems when they weren't practicing with the notes. So 2,000. I'm going to press the second and LN button to get the E that builds in the exponent. If you have the older operating system, it will start parentheses for you, so you don't need to start the parentheses. 0.075 times 20. And again, the older operating system, close it, those parentheses, and there's your amount. So you're going to get, when you're done, $8,963.38. Okay? So now your friend's going to do this with the other formula, compound quarterly. So for principal, he's still doing $2,000. And now he's going to do 1 plus his rate. And his rate is 8%, which is 0.08 as a decimal. And since he's compounding quarterly, that n is going to be a 4. And then that 4 appears again in the exponent, and then after 20 years. So as far as the calculator goes, you will need to wrap extra parentheses here, and the older operating system, parentheses here. All right, so 2,000, parentheses 1, then your other parentheses. The exponent, so again, some of you need to put parentheses here, or you could just type in 80. And so your friend's going to get a little bit more money. He's going to get $9,750.88. So it's not about how often they compound the interest continuously versus quarterly. Even though you're getting interest more often along the way, it's more about the interest rate. You want a higher interest rate. All right, so when will you have a balance of $3,000? So I'm going to go back to this equation, and that 3,000 is going to go in for y. And the other side is going to be 2,000 with the E, still at that 7.5%. But now we don't know time, so we're going to put x in there. And as I told you guys the other day, we don't know how to solve for this yet. We just don't get x's own room. This can only be solved at this point with the graphing calculator. So this is going to be y1. That whole side's going to be y2. So go to your y equals button. 3,000. And then 2,000, get your E, second ln, and then 0.075. And don't forget the x. I had a lot of students yesterday forgetting the x. So start with zoom 6, standard window. This isn't going to fit in a standard window, but you should always start with there. So we're waiting for it to graph. It's not going to graph, the little wheel spinning, because it doesn't fit from -10 to 10 or -10 to 10. All right, then I'm going to do zoom fit, which is zoom 0. All right, so here comes the 3,000. That's just y equals 3,000. And now here comes the 2,000 with the E. This is our exponential growth curve. And the point that we're looking for, our important point, is right here. So first I'm just going to draw a quick picture. Here's the line going across. Here's the curve, and I'm looking for this point. So if you remember second trace, choose option 5, and choose intersect 3 times, or enter 3 times. So you get 5.4 and 3,000. So the question was, how long is it going to take us to get 3,000? That's going to be the 5.4 years. All right, those are your notes. So at this point, we're going to go to another video for the homework and try those. It's going to be a longer homework assignment, but that's okay. We'll have plenty of time to work on it. Okay.